Let's have a look at question 2 in this video. So a professor predicts that 60% of students will buy a new copy of the book in the campus bookstore, 15% will buy it from other stores, and 25% will buy a used copy. So a used copy. Now, the professor does a survey and the students respond. So we have 126 observations. 71 said that they bought it at the campus, 25 said that they bought it at another store, and 30 said that they bought a used copy. So we want to test whether these predictions were accurate, and let's just write the test that we're using and pretty much solve it. So what are we doing here? We're testing a certain distribution. We're testing predictions, meaning that we're going to use a chi-square goodness of fit. So we're using a chi-square goodness of fit test. Now, what is the hypothesis in this test? The hypothesis is that our proportion is right or not. So our data should fit the following distribution. Proportion of students that bought the book at campus equals to 60%, so 0.6. The proportion of students that bought it in another store equal to 15%, which is 0.15. And then the proportion of students who bought used books is equal to 25%, which is 0.25. And the alternative is that data doesn't fit this distribution. So data don't fit this distribution. Now, how do we test it? Well, we compare our expected proportion with the actual proportion, our expected value with the actual value. So let's find out what's going to be the expected proportion that we have for students that buy it from the campus. Well, that's going to be 126 observations times 60%. So 60% out of 126 would be, in expectation, 75.6. Now, what would be the expected proportion for students that buy it from other stores? Let's write the percentage first because it's going to make more intuitive sense. That's 15% out of 126 observation, which is 98.9. 98.9, sorry, 18.9. I didn't understand my own writing. 18.9. And the expected proportion who buy it used books would be 25% out of 126, which is equal to 31.5. Now we have to contrast this with the actual observations. So what is the observations that we see? The observed students that bought it on campus, well, that's equal to 71. This is given. We actually observe it. 25 is from another store, so the observed value from another store is 25. And then the observed value from from the people who used a book, actually bought a used book, I'm sorry, is equal to 30. What we're doing, we're comparing these values. Are they different enough from each other or not? So let me zoom out to get some more space. Let's do it here below. We're comparing them by using a chi-square test, and the chi-square test has the following form. We're taking the sum of all the differences between the observed value and the expected value to the power 2 divided by the expected value. So what would be the math here? Chi-square equals 2. That would be the first difference, this set. So 75.6. Actually, let's do it with, it doesn't matter who we're going to write first because we take the difference to the power 2 anyway, but just to keep track, to make it more understandable. 71 minus 75.6 to the power 2 divided by the expected value of 75.6 plus, we add all these differences because it's a sum. Now we take the second set over here, which is the difference between the observed 25 minus 18.9 to the power 2 divided by 18.9 plus, and the last set, this one, 30 minus 31.5 to the power 2 divided by the expected value of 31.5, and that's equal to a chi-square value of 2.32. Now, just like with any other test, we want to compare this with the critical value. So the question is, what is the critical value here? Well, the critical value of a chi-square, which is only one-sided, so at 5% level, the critical value has number of groups k minus 1 degrees of freedom. So we would have the chi-square critical value at 5% of 3 minus 1, because we have 3 groups, 3 proportions. It's going to be 2 degrees of freedom. And the critical value is 5.99. So let's draw a conclusion on a graph from these two. Let's draw the chi-square distribution over here, which is one-sided, looking something like that. This is the chi-square distribution. 5.99 is our critical value, so let's plot it on the graph. The rejection region is everything to the right of it. And now our value is 2.32, which is to the left, which is somewhere over here. 2.32. So we can see that it is not in the rejection region, meaning that we do not reject the null hypothesis. So we don't have evidence that the proportion differs from what the professor said. So not enough evidence that the proportions are different, or that the data don't fit the distribution. And before finishing the question, let's just look intuitively. Does this make sense? If we look at the actual observations, 71 is not that different from 75.6. 25 doesn't differ much from the other one, 18.9. And 30 is very close to 31.5. So indeed, intuitively, we can see that the differences are not that high, but the statistics, the actual test, just proves it. And we are done.